systems of linear equations in two variables. Okay, so here we have two linear equations, and this is a system of two equations in the variables x and y. It can be in two other variables. You could have u and v, or you could have something else. Okay, now to determine whether the ordered pair of 6, -5 is a solution of the system, we check whether x equals 6 and y equals -5 satisfy each equation in the system. Okay, so each equation. Okay, so that should be equation. Okay, and then here we're supposed to check which of them are solutions. So let's check this one first. So x equals 6, y equals -5. So they have to satisfy both equations. So if we take the first equation, 4 times 6 plus 2 times -5 equals 22. Let's see, does it satisfy that? That's going to be 24, and that's going to be -10. And that doesn't work, so that's not going to work. Then we check this one. Let's see, 4 times -5 plus 2 times 4, is that 22? And that's what, -20 plus 8. That doesn't work either, so that's not going to work. And then we can try the third one. Because the first two didn't work, then for sure the third one's going to work, right? If we have to check in the first equation, 4 times 3 plus 2 times 5. So I'm just plugging a 3 in here and a 5 in there. Let's see, does that work? So this is 12 and that's 10. That works, okay? And then I have to check it in the second system also. Okay, so if the first one works, then it doesn't necessarily mean it's going to be a solution. You have to check it in the second equation as well. So 5 times 3 minus 5 is at 10. So this is 15 minus 5. That works too. So that means this is a solution. And those other two aren't. Okay, so let's look at number 2. A system of equations in two variables can be solved. Okay, there's 3 different ways to solve these systems. There's elimination. And we'll kind of touch on each of these. There's substitution. And then there's graphically. Graphical, so doing a graph. And now when you have these systems of equations, there's 3 possibilities. You could either have one solution, or no solution, or infinitely many solutions. Okay, let me explain this a little bit. Okay, so one solution would be where you have two. So see these, you have two systems of linear equations. These are both the graphs of lines. And if the lines intersect, that's going to be a solution. Okay, so if you have 2 lines that intersect like that, then that's going to be one solution. And it's going to be where the 2 lines intersect. Okay, now you could have no solution. No solution would be where you got parallel lines. You got parallel lines, and then there's no solution. And then infinitely many solutions would be where you have, say that's one line, and let's say that your other line is just the same line. Okay, so if these are both the same line, then you'll have infinitely solutions, and any value along that line is going to be a solution. Okay, so you have infinitely many solutions. Okay, so those are the 3 possibilities. Let's look at the exercises and try to go over and see what happens. Okay, so the graph of the first equation is the same as the graph. So this is the third case where there's infinitely many solutions. because you notice that this second equation is just 2 times the first equation. Okay, so this has infinitely many solutions. We express these solutions by writing. Okay, so one way to do it, and what they want you to do for this section, is to just let x be a third variable t, and which is also known as a parameter. So you let x be t, the parameter, and you take either of the equations and you put that t in for x, and then you solve for y. Okay, so y equals 5 minus t. And so what happens is this is a way to express all of these infinitely many solutions. Each value of t will give you a solution. So, for example, here x is 4, which means that t is 4, which means that y is 5 minus 4, which is 1. Okay, so for 1 will be a solution, will be one solution, which is the one point on this line here. Here, again, this is going to mean that t is -4. And so y will be 5 minus a -4. That's going to be 9. So -4, 9 will be a solution. And then here this is telling you that t is going to be 5, which means that y will be 5 minus 5, or 0. Okay, so that'll be 0. Okay, so this is just one way. This is one way of expressing when there's infinitely many solutions. Okay, now let's look at another method, the substitution method. Use substitution method to find all solutions of this system of equations. Okay, with the substitution method, what you want to do is the first thing you want to do is solve for x or y in one equation. And you just look for the easiest one to do, and it's going to be the top equation, because you can just take the 2x over to the other side. So y equals 5 minus 2x. Okay, and then number 2, so I've done that. I've solved for y. And number 2 is you plug or substitute into the other equation. Okay, so the other equation is 3x plus 2y equals 4. And so what I'm going to do is I'm going to take this quantity, I'm going to plug it in for the y. Okay, and that's going to give me this. Okay, and then third, I'm going to solve that equation. So that's because now I only have one variable. That's the idea. And it's 4x equals 4. Let's see, the 10 goes over here. This is negative x equals, and the 4 minus 10 is -6. So x is okay, I copied this down wrong. I copied this down wrong. This should be a 5. Okay. So these are 5s. Which means that that's a -5. So x is 5. Okay, so x is 5. And then so you solve that, and then what you do for the end one is you plug it in, you plug this 5 into here. Okay, and then you write your answer as an ordered pair with the x value first, followed by the y value. So 5, -5 will be the answer. Okay, now they're already in there in Webassign, they already have the parentheses drawn for you, so you're just going to do the, so you're just going to put in this inside part right here. How convenient. Okay, number 6. Now the elimination method. Okay, so what you want to do for the elimination method is you want to multiply the top equation by something and possibly multiply the bottom equation by something and get new equations and then add those equations together and eliminate. You're trying to eliminate, so you, depending on what you multiply by, you can eliminate one of these variables. Like for example, I see that this is -5 and that's +4. So if I multiply the top one by 4 and I multiply the bottom one by 5, then this is going to, then the y term is going to be -20y, and the y term here is going to be +20y, and those will cancel each other out when you add them together. Okay, so this will be 8x minus 20y equals -16. The bottom equation is going to be 15x plus 20y equals 5 times. What is that, 85? I guess that's 85. Yeah, that's 85. Okay, so now I'm going to add these together, and that gets eliminated. Okay, eliminated. Okay, so that's the idea. So add those together, that's going to give you 23x over here. That's going to give you 69. So if I divide both sides by 23, I get x equals 3. Okay, so I've solved for one of the variables, and then I'm going to plug this into either of the equations. So maybe I'll plug it into the first equation right here. So 6 minus 5y equals -6. So -5y equals -12. Wait, what's that? Wait, this is negative. I'm getting really sloppy here. Okay, so this is -4. Okay, so that's going to be -10. So that means that y, -5y, wait, I'm really sloppy. That's -4. Okay, so that's going to be -10 right there. That means y, divided by 5 on both sides, it means y is going to be 2. So our answer is going to be 3, 2. Oops. I got to be more careful. Okay. So 3, 2 is the answer to that one. Okay, number 7. Okay, so 2 equations and their graphs are given. So we have the red one is one of these equations, and the blue one is the other. Okay, the red one is this second one. The blue one is the top one. The blue one is the top one. Okay, find the intersection point of the graphs by solving the system. Now you have the graph, so you can just use the graph to solve the system. This point right here represents the solution, and you can see that the y coordinate is 8, and the x coordinate is 4. Okay, so or -4, and y is 8. So that means that the solution will be -4, 8. Okay, so you can solve these using graphs. Okay, let's just do some general problems. This one right here, solve the system or show it has no solution. Okay, right here, already we can add these two together and eliminate the y. So let's go ahead and do that. So that means 6x equals 18. So the y's get eliminated. That means x is going to be 3. Okay, and then you're going to take the 3 and plug it into, let's plug it into the first equation right here. So 2 times 3 minus 3y equals 9. That's 6 minus 3y equals 9. Subtracting 6 from both sides, you get 3y equals 3, so y is negative 1. Okay, so that means that the x value is 3, the y value is negative 1. Okay, let's look at the next one. Now, sometimes it's helpful to divide by common factors. So you can see that all of these are divisible by, all the terms here are divisible by 4. So let's just divide by 4. Okay, so and then we'll see what we get. So that's negative x plus 3y equals, let's see, 60 divided by 4 is 15. Everything here is also divisible by 4, so we'll just divide everything by 4 as well. So 12 divided by 4 is 3, so 3x. Divided by 4 is 1, so that plus y, and then 180 divided by 4 is 45. Okay, so that's going to be 45. Okay, now maybe the easiest thing now is to, let's do this. Let's take this top equation and solve for x. Because like if you can use if you can do substitution, then may as well just do that. So negative x is going to be, so bringing the 3y to the other side, negative 3y plus 15. But then you multiply by negative 1 and you get this, so 3y minus 15. And then this one is going to go in for your x right there. Okay, so 3 times 3y minus 15 plus y equals 45. Okay, so let's see here. 9y minus 45 plus y equals 45. Let's see, 9y and y is 10y. And adding 45 to both sides, you get a 90 over here. Okay, so dividing everything by 10, you get y equals 9. Okay, so there's our one solution right there. And now you're going to plug that into here. And 3y minus 15. Okay, so x is 27 minus 15, which is 12. So x is 12. And that means our final solution is 12, 9. Okay, let's do more of these. So number 10. Okay, this is an interesting one. So let's see here. Maybe we could solve the top one for x. So x equals negative 4y plus 12. So we'll substitute this into the x right there. Okay, so that's going to give you that, okay? So I just took the second equation and replaced the x with this, left everything else the same. So now we distribute in, we get negative 12y plus 36 plus 12y equals 2. Now, the 12y's are going to cancel out, and you're left with 36 equals 2. Whoa, that's funny. That's weird. 36 equals 2. What? How's that? So then you're like, whoa, what's going on here? Okay, what happened here is 36 isn't equal to 2, right? It will never be equal to 2 as far as numbers are concerned. So this means that there's no solution. Okay, so when you get to that point, then that means there's no solution. Because 36 is not 2. If you do this by elimination, then you'll also come up with some weird thing. It might not be 36 equals 2, but it'll be something else that's clearly false and can never be remedied. Okay, here's another situation. It could happen. This is really similar to the last one. Or is it? Okay, so I can take the top equation, and if I take the top equation and divide by 2, that gives me 5x plus 2y equals 6. And then if I take the second equation and divide everything by 3, I get 5x plus 2y equals 6. I get the same thing. That's the same equation. And if I were to so these are the same equation. And so you can throw one of them out. So basically, they're the same. And that means that you have infinitely many solutions. Okay. So what it says, what the instructions say are, if there are an infinite number of solutions, enter the general solution in terms of x, where x isn't a real number. Okay, so and earlier on the exercises, they told us to let x be equal to t, which is a parameter, and then go with that one, but they're telling us to just let x be itself. Okay, so here's what it's going to do. There's only one equation now, basically. Instead of having a system, you've got this equation. Everything that satisfies this equation is a solution. So, and they said let x be itself. So what you're going to do is you're going to solve for y. Okay, so 2y is equal to negative 5x plus 6. So y is negative 5x over 2 plus, I'm dividing everything by 3, by the way, so this is 3. Okay, so I can write it like, maybe I'll write the 3 first. 3 minus 5 halves x. Okay, and now what you're going to do for an answer is you're going to lead off with the x, and then in the first spot you're going to have an x. The second spot you're going to have this right here. Okay, and that'll be that answer will work. I think that's the only answer that's going to work, unless you have some equivalent form of this. Okay, so just let x be itself, find y in terms of x, and then write it like that. Okay, and then any value of x will give you a solution, because there's infinitely many values of x you can put in there. Okay, here we have u's and v's. So let's go ahead and work on this one here. Since we can, it's probably easiest to solve the first one for u and use substitution. So I got that, and then we're going to plug that into. We'll plug that into the into here. Okay, distributing in -3, you get negative 90 v plus 405 plus 80 v equals 355. Okay, so adding that and that together, you get negative 10 v, and then over here you got 50. Okay, so subtracting, oh wait, negative 50. So subtracting 405 from both sides, you get negative. So 355 minus 405 is negative 50. Okay, so dividing by negative 10, you get v is equal to 5. Okay, and then you're going to take that 5 and plug it into here. So that's 150. Dang. Stop. That's 150 minus 135. So U is 15. Okay, so your answer is going to be, because so U comes before V in the alphabet, so we're going to do the value for U first, which is 15, followed by the value for V, which is 5. So 15, 5. Okay, now number 13. Okay, the admission for amusement park fee is $1.50 for children and $4 for adults. On a certain date, 2,400 people entered the park, and the admission fees that were collected totaled $5,350. How many children and how many adults were admitted? Okay, so it's asking how many children and how many adults, right? So let's do this. Let's let X equal the number of children. And let's let Y equal the number of adults. Okay, so when it's telling you to find, so when you have a stripe problem, one of the things you look at is what is it asking for you to find? That's really important that you understand what it's asking for. And then usually you're going to let your variables be what they're asking you to find. Okay, so X is the number of children, Y is the number of adults. Okay, now if 2,400 people entered the park on a particular day, that translates to X plus Y equals 2,400. Okay, so the number of people that enter the park is the number of children plus the number of adults, right? So X plus Y is 2,400. Then the admission fees were this much, okay? So for each child, it's $1.50, and for each adult, it's $4. Okay, so that's how they get that. Okay, so this is what's going to be collected. So for each child, they're collecting $1.50. So the revenue from children is 1.5 times the number of children, and then it's $4 per adult. So the revenue for adults would be 4 times the number of adults, and then the total revenue is $53.50. Okay. So usually I don't like fractions. I don't like decimals or fractions because that kind of messes things up. So let's go ahead and multiply this by 2, and that will get rid of that. So I'm going to have 3x plus 8y equals, let's see, 10,700. Okay. Now, this looks like a substitution again, or let's do this. Let's just multiply this by -3. And so I got -3x minus 3y equals, let's see, 2,400 times -3 is -7,200. Okay, so let's do that, and now we'll add these together. So the x's cancel out. The y's is this -3y plus 8y, that's 5y. Okay, and then 10,700 minus 7,200, that's going to be 3,500. Okay, and then dividing by 5 on both sides, that's going to give you 700. So, oops. 700, okay? Okay, so that means there are 700 adults. Now, let's see, come back to here. So X plus 700 is going to be 2400. So I'm going to plug this 700 into here because this is the easier of the two equations. So X is going to be 1700. So 1700 children and 700 adults. Okay, great. Number 14. So here we have money, so we're going to go green. A man invests his savings in two accounts, one paying 6%, the other paying 10% simple interest per year. He puts twice as much in the lower yielding account because it is less risky. His annual interest is $3,740. I mean. How much should he invest at each rate? Okay, so this is the question right here. So we're going to let X be the amount that's invested at 6%, and we'll let Y equal the amount at 10%. Okay, now let's dissect this. This is the easiest statement right here to find the equation for. It says he puts twice as much in the lower yielding account. So this is this one right here. This has twice as much as that. Okay, so that means that X is 2Y. Okay, that just comes from that. Twice as much. So the X one is twice as much as that one because it's less risky. Okay, so X is 2Y. That's our first equation. The second one comes from here. The annual interest is $3,740. Now, if you're 6%, this is earning 6%, okay, over the year. So that the interest from this first one will be 0.06 times X. The interest from the second one will be 0.1 times Y. And that adds up to $3,740. Now, let's see here. Let's get rid of these decimals. So and also this looks like a substitution problem because really this can just go right into here. In fact, let's just do that. Let's just put the 2y into here. Okay, and so this becomes, let's see, 2 times 0.06 is 0.12. And then these two combine to give you 0.22y. So y will be 3740 divided by 0.22. Which is 17,000. Okay, and then we know that X is going to be 2y, so X will be twice that. Okay, so those are our two answers. So then the 6% will be $34,000, and 10% will be $17,000.